Hello everyone and welcome to Thermodynamic Shorts. So in these videos, I'm going to try to go make a very short video that sort of summarizes the topics that we've been talking about in thermodynamics class at RIT. So the first topic that I want to cover in these shorts video is the syllabus. How are we going to calculate your grade in this class? So like many classes in RIT, we're going to give you 10% for your homework, 10% for your quizzes. The first midterm will be worth 25%. The second midterm will be worth 25%. And then the final is worth 30%. Now, you may have heard coming into this class that thermodynamics tends to be relatively difficult. And we'll end up asking you difficult questions in exams because we think that's how you learn best. We don't want to spare you the struggle. So instead of using sort of the prescribed grade breakdown that RIT uses that you can find on the website where X% leads to Y letter grade, we're going to look at the distribution of grades in the class at the end of the class. So we'll take approximately the top 22% of the class and they'll get some description of an A, whether it's an A or an A minus. The next third of the class will get some kind of a B, and then hopefully the rest of the class will get some kind of a C, but we may also have up to 12% of D's or F's, sort of DWF rate of around 12%. Now these are the typical breakdowns that you'd see for students in these different bins, but we're not militant about this. We'll look at the actual distribution of grades and try to find natural breakpoints and bin students into these different letter grades. And of course, if everyone ends up with over 90%, then everyone will get an A. So we will use the university prescribed sort of transition from numerical grades to letter grades if they benefit the students. But if not, we will use a distribution like you will see where you sit in this distribution after each midterm. So you'll get a sense of what your letter grade would be if the class ended on that day. Now, it's important to remember that the class doesn't necessarily end on that day, right? So if we have midterms in week 5 and week 10 and then the final after week 15, I'm most concerned with what you know at the end of the class. So if you end up having a bad day in week 5 or in week 10 when you write the midterms, it's okay because this class is cumulative. So if you do better on your final than one of your midterms, we will overwrite your midterm grade with your final grade so that the final will be worth 55% instead of just 30%. Now, we will only do this to overwrite one of your midterm grades, so the midterms do still matter, but it is possible for you to demonstrate your understanding at the end of the class and for that to count more than it looks like just by the pie chart here. So what does a typical week in thermodynamics looks like? We're going to have lectures on Mondays, Wednesdays, and Fridays. And if you look on the syllabus, there are homework problems that are associated with each one of those lectures. Now, every Wednesday on the My Courses site, there will be a quiz that's assigned to you. So that quiz will open up on Wednesday and the quiz will close at Sunday at 11:59 p.m. or at 23:59, so just before midnight. You can leave your quiz open that whole time. It's not a timed quiz except that it's only open for these 5 days. Now your homework from the previous week will be due Monday at midnight as well. We'll take your 10 best quiz grades over the course of the semester. So I think there's 14, so we'll drop your 4 lowest quiz grades. But we will take your homework grade as being the average of all the homework sets that you do throughout the course. So how do we grade your homework? So let's say you have a homework that looks like this, where you have 6 different problems. What the TA will do is randomly select one of these problems, and that will be graded more rigorously than the rest of the problems. Here, we're not so much grading for did you get exactly the correct answer. We're grading for did you follow the right process. So did you attempt the problem? Did you follow the correct format that we're using for homework? Did you use the right solution method? Did you do things like tell us what your assumptions are? Did you check your units throughout the calculation? Did you comment on whether or not the sign of your answer makes sense according to your physical understanding of the problem? Now, the rest of what we'll do is the TA will look at all the rest of the problems in the homework set and say, well, did you make an honest attempt to complete the rest of those problems? So you'll have one problem, which you won't know beforehand, that's worth 7 out of 10, and the rest of the problems we're basically just checking to see, did you make an honest attempt? Finally, this is something that's maybe a little bit different in thermodynamics than in some of your other classes. We're strongly encouraging you to come to our office hours. Now, office hours will be done in Zoom this year, and we'll have a link to the Zoom meetings on the course website. So you can come in and talk to us about problems. We won't solve homework problems for you, but we can certainly talk about the methodology and what's the process that you should follow to be able to solve a particular homework problem. Now, again, what's maybe different about this class versus other classes is that you will have a graded office hour visit that you have to come to one office hour visit in the first 3 weeks of the class. Now, this is going to be the easiest grade that you ever get here at RIT, so please come. You just have to come to the office hour, show us that you're, willing to come and see you. We sort of want to demystify this process so it's easy for students to come and see us if they have questions. So I just want to invite everyone, please come to the office hours. I think it's a very good way to learn, especially if you have questions about the material that we're covering, and we can work together to try to get you answers to those questions so that you're on the right path. Thanks for joining me. I'll see you next time.